Let's solve this question. The following figure shows the road network between two towns A and B. This is town A and this is town B. How many distinct shortcut routes exist from A to B? I need to find how many distinct short routes exist from to reach B from A. Now this grid is like this is this and this is town B and this is town A. I have to reach B from point A, and these are the road network between A to point B. Now this is classical question of permutations and combination. Let's see how. Because I can reach A to B through multiple roads, and it would be very hectic to calculate these each road one by one, and it would be very confusing because one such route would be this, when it takes one step in horizontal direction, then in vertical direction, then in horizontal, then in vertical, then in horizontal, then vertical, and then vertical. Second route can be if A takes 2 steps in vertical direction and 2 steps horizontal direction, and then 2 stops vertical and 1 point horizontal. And one such road would be one route can be when A take 1, 2, 3, 4 steps vertically and 3 steps horizontally. So to calculate these different routes, what I have to do is let's just first count how many steps are there which one needs to take to reach B. So he needs to take in each route, that is, if I take this route, this is route 1. In this route, someone is taking one route, this is in horizontal direction 1 step, second in horizontal, and 3 steps in horizontal. So he has to take 3 horizontal steps and 1 vertical, 1 and 1, 4 vertical steps. In route 2, if this is route 2, someone has taken 2 vertical and then 1, 2, 3 horizontal and then 2 vertical. So 4 vertical and 3 horizontal, same. And in this route 3 also, first 4 vertical steps are taken and then 3 horizontal steps are taken. So 4 vertical plus 3 horizontal. So the total number of such routes would be nothing. Total routes would be nothing but the total number of ways of arranging 4V and 3H. If I arrange V and H, I'm getting one distinct route, right? If I write V, H, V, H, I'm getting one route. So getting the total routes is all about arranging these V and H. And there are 4 V's and 3 H. And the number of arrangements of these 4V and 3H is equal to how many total objects are there? 4V's are there, 1, 2, 3, 4, and 3H, 1, 2, 3. So there are 7 objects, and arrangement of these 7 objects is given by 7 factorial upon 4 factorial into 3 factorial. I'm dividing this expression by 4 factorial and 3 factorial because these are identical ones. So 4 identical objects of one type and 3 identical objects of other types. So the total number of arrangements would be 7 factorial upon 4 factorial into 3 factorial. That is 7, 6, 5. 4 factorial get cancelled. 3 factorial is 6. So this get cancelled, 6 get cancelled. Total number of such roots would be 35, and that I'm getting the answer as 35. But if I look at the options, no option says 35. It means that I have added, because all the options are less than 35, so I have added, or I have taken into account some root which does not exist. So I have to subtract such roots. One such root would be in the arrangements. In these arrangements, I have counted one root as when 2h are there, when first I take 2 horizontal steps and then I take further 5 steps in any possible combination. But if I take 2 horizontal steps, is that possible in a given scenario? No, because A can only take, initially A can only take one step in horizontal direction. It cannot take other step in horizontal direction. He has to take one vertical step then. So I have to subtract all such roots or all such arrangements which starts with 2h. Now after these h and h are placed, I have to place 4v and 1h. In these 5 places, 4v and 1h. Now the arrangements of this type would be 5 factorial, 5 objects needs to be arranged in which 4 are of same type. So upon 4 factorial, so total number of such roots would be 5. These 5 roots needs to be subtracted. Second, this is these are one type of roots that does not exist. Second type of root that does not exist is when A takes 2 steps in vertical direction, that is V and V. If he takes 1 step in vertical direction and he takes 1 step, 2 step and 3 steps in horizontal, because there is no horizontal step there. So this root is not possible. So when A takes 1 step vertically and 3 roots horizontal or 3 steps horizontally, then 1, 2, 3 steps needs to be taken. This root does not exist. Now I have to arrange 3 V's there, and only one such root would be there, because arranging 3 identical objects would be 3 factorial upon 3 factorial, that is 1. So one such root would be there that does not exist, in which A takes 1 vertical step and 3 horizontal steps. This is not possible. Third such root, when A takes 1 horizontal step, 1 vertical step and then 2 horizontal steps, H and H, which is again not possible. So I have to arrange 3 V's, and again it is equal to 1, because 3 identical objects can be arranged in only one way. So total number of such roots that does not exist is equal to 5, 1 and 1. That is 7 such roots are there which does not exist. So I have to subtract such roots to get the total number of possible roots. So total possible distinct roots would be how much? 35. That is to the number of arrangements of 4 V's and 3H minus all such roots which are not possible. And how many roots are there? 7 such roots are there. So the correct answer, total number of possible distinct root would be 28 roots. So the correct answer to this question would be option D.